Hello everybody, Anand here again. Today we're going to take up a very interesting topic, that is permutation and combination. It's something which, it's a very important applied form of mathematics which you use in daily life. Of course, a very important part of statistics also, wherein the concept of probability is definitely involved. Now we need to understand what exactly permutation is, what is a combination. In simple words, permutation is a kind of an arrangement of whatever you have selected, and combination is just selecting certain items out of a given set of items is what you mean by combination. It could be combining two or three words. Say suppose you want to form a committee of three people out of a people of 10 people. So you may select A, B, C, or you may select B, C, D, or you may select B, D, A, any such combination. Now, if you select A, B, C, or you select B, C, A, it means the same, or you select B, A, C. The order in which you're selecting A, B, and C, whether you select A first or you select B or C, it doesn't really matter. As long as you select A, B, and C, it means the same. So it's basically a combination. Now go into a situation wherein you're selecting A, B, and C, and then you need to arrange them for a photograph. Now the order is important. Who's on the extreme left, who's on the extreme right, who's in the middle. So if it is A, B, C, it's different from B, A, C. And that's different from C, A, B, and that's different from C, B, A, and so on and so forth. So in short, it means that just selecting is like a combination. You're just selecting certain number of items, say R items out of N items of the lot. We call it as a simple combination, where the order in which you select is not very important. But after you select, you have the concept of arranging them. Now, once you get into the concept of arranging, the order in which you arrange is very important. This is especially true for creating numbers out of digits. So suppose you choose 1, 2, and 3, and if you make it 123, it's different from 213, and that's different from 312, and that's different from 321. So we have a large number of such possibilities that arise when you arrange the selected numbers. So it's an interesting relationship between permutation and combination. So these are the kind of things that we will be covering up in this particular topic. So let's see what things we have in hand here. So if you look at the overview of it, you have basics of permutation and combination, starting on similar lines with what I talked about, wherein we'll understand what permutation is, what a combination is, where and all we apply them. Then we go into what a permutation. We're going to talk about permutation, the various types of permutation and various types of arrangements. You'll have row arrangements of permutation or along a circle. Then in that case, so in case of a permutation, you may have something like this kind of arrangements, wherein certain things are chosen out of a given number of things and you arrange them in a row. Or you could have this kind of an arrangement wherein certain number of chosen and they are arranged around in a circle. So in such cases, this situation, this particular situation is different from this situation. So this is permutation. Then we have combination. Combination is just checking how to pick up the concept, how to pick up certain number of terms. So you need to pick out 3 out of 10. So how do we pick up? What are the ways in which we can pick up these things? And then various types of properties of these combinations. Now, once we have done with permutation and combination and various types of problems, if you master these simple concepts of permutation combinations, you're almost 90 to 95% thorough. Now, beyond this, we need to definitely test whether whatever we have learned is something which we can apply in a different kind of setup. So hence, we're going to take up uncommon problems based on permutation and combination. So, should we move ahead? I think we should be.